Hi everyone, we're going to talk today about linear functions and take some specific notes about those functions. We've talked about functions, we've talked about linear functions and lines. We're going to talk specifically about the formalities of these linear functions as we take these notes. A linear function is a function whose points, their points x and y, lie in a line, and we know that we've talked about lines. A linear relation, we say formally, is any equation that can be written in the form ax plus by is equal to c. And in that equation, a and b can't both be 0. So we'll say ax plus by equals c with a and b not both 0. One of them could be 0 or the other one could be 0. The coefficient of x or the coefficient of y could be 0, but they can't both be 0. If they're both 0, we don't really have an equation at all. So this form of the equation is not really what we've looked at yet. This is called standard form of a linear equation. And we want to notice a couple of things. We'll recognize these equations as being linear equations because there's nothing suspicious about them. And there's a little asterisk here. I had a student once who, that was how he referred to them. There's nothing suspicious about them. We recognize it's a linear equation. So what does that mean? Well, let's see. It means that for that equation, ax plus by equals c, the x and the y are both to the first power. Now notice in the equation we don't write in the exponents of the x and the y. It's kind of understood that if there's no exponent there, it's a 1. So that's one of our most important points here, is that x and y both raised to the first power. Or the power of 1. I'll write first power. You could say to the power of 1. So that's the main thing. If you have an x squared or an x to the third, it's not going to be a linear function. It could still be a function, but it's not going to be a line. Okay, so we look for an x to the first, a y to the first. That's what's going to make it a line. It also means that there's some things that are not linear functions. There's no square roots, no variable under a square root. So like no square root of x or square root of y. There's no x or y in an absolute value sign. There might be a number in an absolute value or a number under a square root, but there's no x or y within that square root symbol. There's no variable like an x or a y in the denominator of a fraction. You could have an x or y in the numerator of a fraction. But again, nothing suspicious here. No absolute values, no square roots, no weird exponents, no fractions with x or y in it. Nothing suspicious. And we recognize a linear function. That means that whenever we look at an equation, we should be able to tell if it's linear or if it's not linear. So if I gave you the equation 2x minus 4y equals 9, you would say, yes, that's linear. We have x and y both to the first power. It can be written in that form, ax plus by equals c. If I wrote that and asked you what a, b, and c were, you would tell me a was 2. It's the coefficient of the x term. B would be negative 4. It's the coefficient of the y. And c would be 9 if I asked you for the coefficients in standard form. We could see an equation like y equals x. Is that linear? Well, let's see. The x is to the first power. The y is to the first power. Yeah, that's linear. There's nothing suspicious about it. No x under a square root, no y under a square root, no absolute values, nothing strange going on. We could have parentheses. We could have fractions. We could have negatives. Y equals negative 2/3 times x minus 4 plus 7. Yeah, that's linear. The x and y are to the first power. There's parentheses, but if I rearrange some things, I could write it as that ax plus by equals c. These things are not lines. So here's some examples, counter examples, things that aren't lines. If I gave you the absolute value of y plus 2 equals x, it doesn't look that suspicious, except we have that absolute value around the y. That's going to make it not linear. Or if we had x squared plus y squared equals 7. Because of those x squareds, it's not going to be linear. We could plug those into Desmos, check to see if they're lines or not, but visually we should be able to inspect an equation and decide if it's a line or not. Lines are a really simple example, just x to the first, y to the first. If we had something like 1 over x plus 1 over y equals 1, that's not going to be linear. Even just 1 over x plus 3 equals y. So just the x's in the denominator, still not linear. They're not going to make up a line. It's not going to look like a line unless the x is to the first power, the y is to the first power, nothing else suspicious going on within that equation. Now just a note here about that standard form, that ax plus by equals c. Again, that's called standard form of a line. Usually we say that a, b, and c are not fractions, if we can avoid it. And we also like the a, the leading coefficient, to be positive if possible. So we'll say greater than or equal to 0. So in other words, if I had an equation negative 4x minus 2y equals 6, that's not really considered standard form because of this negative sign. So what I could do is divide the whole thing through by negative 1, and that would change all the signs. Now my equation would be 4x plus 2y equals negative 6. Now that's considered in standard form. But mostly what I want you to do right now is be able to recognize, is it a line or is it not a line? So you've taken the first page of your notes. Let's pause here, do the second page in the next video.